this group. Within this group and within this gathering, you can you can develop your R skills, write excellent R code, but eventually you need to distribute it. Eventually you will reach a point where you need to make a collection, kind of bundle all these individual R scripts that you have written, turn them into a package, either for your own convenience or for the purpose of distribution and publishing. So today I'll be talking about some rather old techniques, some old way of doing package development in R. And I hope you find it useful. Before I go ahead, can someone please confirm if you're seeing the slides in the presentation mode? Is it all good?
It's all good.
Excellent. So let's go ahead. So if you're new to all these R package developments and you need a comprehensive guide, all the introductory stuff, from all the introductory stuff to all the way to the more advanced techniques, I highly recommend these R packages from Hadley. Hadley has been over years developing a number of packages that just makes it way more easier to build the building blocks of the package, and it has just made package developments within the R environment very much easier. So this book is in English, but it's free and it's available to everyone. Everyone can access it via the link over here. So I strongly encourage and recommend that you go through this book in your own time if you want to get more high-level understanding of how to do R packages. So my talk is going to be very superficial today, but I'm going to cover superficial, but yet covering the most like the core topics, the core techniques that you need to know to build your very first R package. And I'll try to do a demo, and let's see how it goes. So I'm gonna start by talking about 3 avenues that are out there for publishing R packages, because that's easier to start with. Then I'll talk about DevTools and Roxygen 2 as the core package development libraries that you need. I'll show you how to create the basics or the building blocks of a package simply from your RStudio session. I hope you're using RStudio. I'll point you to some of the key development workflows. So a series of key commands or functions that you need to know, just to make sure that the whole development process is smooth. And some description of like the package architecture, which you probably become you get familiar with this as we go through the presentation and workshop today. So the main streams for publishing your R package is either via GitHub. GitHub, I presume most of you have heard about GitHub. This is like an online repository. When people publish their code, it's actively used for software development. It enables tracing of different changes that you applied to your software or package. And of course, it has lots of other advantages, like it makes collaboration for software development much more easier. Also distribution of code. You can just put your code on GitHub and share it with the rest of the world. But at the same time, you can actively develop your code, actively maintain your code. So every time that you make a change in your code and you push it to GitHub, everyone who has been using that repository and your code will have access to the latest version of the software or the package, and so on and so forth. So if a package is still under active development and you feel that it hasn't really reached the point of proper publishing, GitHub is the place to host your package. CRAN is the official R repository for all the R packages. And I think while we are talking, so CRAN actually has a package submission process. Compared to GitHub, then there is no control or there is no kind of examination of the package. CRAN does have some requirements. So it checks for some of the requirements that the package has and the package needs to have those requirements in order to get published on CRAN. And CRAN is like for a diverse, is a repository for all sorts of R packages, regardless of the discipline. So here, for example, to the right, I'm showing the task view. I think that was a nice point to introduce you to task views in CRAN, in case you haven't heard of it before. But these task views are essentially a collection of all the R packages that exist that are published on CRAN. And they are kind of divided or categorized into different disciplines. So if you are looking for example, if you work in the stream on like missing value imputation, for example, you can just head to this CRAN task view, click on this missing data topic, or I don't know, Bayesian statistics or anything else, and just get a list of all the packages that are under active development in CRAN and are hosted on CRAN. And the idea is that you don't want to reinvent the wheel. You don't want to duplicate a work if it currently exists, or you don't want to duplicate a name for your package if the name already exists. And so using CRAN task views is a good resource to refer to, but it's for application, like using those packages. Or developing your packages on top of other packages that currently exist on CRAN. Bioconductor, I come from a medical research background. So for us, Bioconductor is the main stream for publishing our tools. So Bioconductor is an open source repository similar to GitHub, but it's an open source repository specifically for bioinformatics software tools. So if any one of you works in bioinformatics or medical research or computational biology or systems biology, Bioconductor is the one that you should consider for submitting your packages to. Similar to CRAN, Bioconductor also sets some requirements for your package in order to be accepted. So CRAN and Bioconductor, it's an acceptance. They have this acceptance system that look for some requirements in your package in order to accept it. So that was it. For package development, there are two really main, at least according to my out-of-date information, dev tools, which is actively used still for building, testing, for build checks, and for all other general purpose development workflows or things that you need to do. Recently, I think Hadley has used this. It's probably not too recent. I think this has been probably around for 4 or 5 years, or even more, or even less. I'm not sure, but I know that people, I think Hadley kind of reformulated most of these DevTools-based workflows for package development into this library, which is a more convenient way. And this is more comprehensively covered in the actual book. Roxygen 2 is the library that is used for documentation. So Roxygen 2 provides a markup. This is a language that we use that language to document the code that eventually makes or builds the help pages that you see when you call question mark function name in R. So DevTools and Roxygen 2 are the main two libraries that you need to know for developing the R package. And now I think it's a good time to move to RStudio to actually show you how to create a R package, and hopefully I need to switch between different screens. So be patient with me. Are there any questions so far? Did I go too fast or was it just okay?
It is okay. Thank you so much.
Okay, excellent.
We are with
so
you.
This is excellent. So this is my RStudio session. It's actually very easy to create a new package. So to create a new package, you just click on File, New Project. I don't need that. You go to New Directory, and there you see a list of different things. And this is the RStudio root. You can use this package or use this library. So let's stay with library and not overuse the word package here. So I'm doing this via the RStudio, but if you're not a fan of RStudio, you just use R. You can call some functions from the use this library directly, and those functions are covered in the book, and that still does the same job that we're doing here. So I'm just gonna click on R packages. I'm just gonna set the path that I wanna create that package. This is a directory that I created specifically for today's tutorial. And I'm gonna,
one of participants asked, would you please zoom screen because it's like tiny.
Zoom. I'm not sure how can I zoom this. Is this the window that I'm moving? Is that small or?
Maybe after configuring this part, you can select the tools, global options. There is a percentage you can change from, I don't know, 100% or whatever. Yeah.
Does that look better?
Yeah. Now it's much better. Thank you.
Okay. Cool. No worries. So I'm gonna just.
Thank you.
All good. I'm gonna just call it the very trivial name, test. I think test. So, yeah, it's gonna be my package name. And if you want to use Git, eventually I think all of us will push all them make it. We want to make sure that we trace all the changes that we make to our code at any stage of package development. So ideally, you should also tick this, create a Git repository. And this just makes it much more convenient for you later to communicate with GitHub or the repository on which this package will be hosted on GitHub. But I'm gonna skip it for today, and I'm just gonna do create project. So you see that it made okay, it needs to refresh itself. So it has, what happened is that it made a this R-Ladies Melbourne directory for me, and by default it just added some files, including a description file, a namespace file, man, which is where your help pages are going to be stored, and R, which is the repository where you will place all your R code. We can probably just have a look at them. So, and by default, it has made a hello.r script, and I'm not sure if I still need to zoom in, but you can see that in that default script, you have these kind of hashes and followed by some words or some documentation So these are all the things that, it's actually not the proper documentation was using Roxygen, but I'll show you how to do that. But yeah, so that's a sample really R code, but let's look at the main files. So description, it kind of speaks for itself. It's a simple kind of text file. It has no extension. So description and namespace don't come really with file extensions. There are just some files. Description is where your package name goes, the type of the package, the title, author name. So you can here put your name, version of the package. So versioning and licensing a package, which you see in line 4 and line 9, are different concepts when it comes to distribution and publishing of our packages. I'm not going to cover them today, but it's covered in depth in the book that I mentioned at the start. And I'm happy to share the slides, by the way, after the session, so that you can go through the slides in your own time. So author and maintainer. Maintainer is the person who actively updates and looks after all the problems that may arise, as for example, different R versions are published, come out, or there's a chance that your package depends on some other R packages. Just consider or imagine if another R package makes a substantial change into one of its function, then your code is likely to completely break. So a maintainer is the person who actively checks for this stuff. And if the package is still built perfectly and with no errors at all time. So author is, for example, let's say I had, it was 5 of us who came up with this idea of this software, but I'm eventually the person who actively is in charge and actively maintains the package. Description is just a short description of what the package is about. License, I mentioned, encoding and lazy data. These are the things that we typically don't change. I think just to make it even more understandable, I'm going to show you like one of my own packages. So this is like I've pushed this package on GitHub. You can see the structure is the same, the R directory, the man directory, description, and namespace are kind of the core element things that the core parts of the package that stay the same. Then depending on what you need to add or enhance your package with, there also could be optional directories like data, where you keep your data, vignettes, where you keep your workflows, the workflows that demonstrate how people should use different functions in your package. But I think to make it more understandable, let's for example, look at the description file of this package over here. So again, package name, package title, version of the package. So one of the things, something that I can probably quickly mention too, note that, by default, the R version is 0.1.0. Every time that you make a minor change to the package, that it's not going to substantially change the functionality of the package. You increment, once you are done with the change, added the new function or make the edit, you increment the last digit of the version. If you are making, over time, you do lots of these incremental changes, and you come up with a big new release. In that case, you need to change the second digit, to increment or bump the second digit of the version. So this version actually makes sense. So this version over here means that it has been through substantial improvements and changes in the functions. And so that's reflected by incrementing these different digits over here. So here, for example, this is how you can specify an author, specify your description for the package. Something else that it's by default not there is the depend line or the depend specification. This is recommended to have. So I'm saying that I'm using functions in my package that depend on R greater than 4.1. System requirements. In this case, I'm also using some Python code. So I'm using systems requirement flag. Let's call it flag. I'm specifying that my function also depends on some Python code. And when I'm writing, in the functions that I've written for this package, I'm relying on some of the other functions that I'm importing from a number of different tools. So these are all the dependencies should be listed in the imports section or imports flag. I'm here using a GPL2 license, which enables everyone to kind of distribute or redistribute or extend my work with no restriction. And some other options that you can add are things like bug reports. Where should bug reports be reported to? So I'm just saying that, if you're using my package and you realize the problem, then, this is the link where you can open issues on GitHub and state what was the problem that you experienced. So the suggest field, every package that you make, you also need to publish RMD files or SUIV files that demonstrate how should one run the codes in your package. For example, what's the order of running different functions in your package? And it's essentially a complete piece of data analysis. It's a demonstration of how one should use your package with some data. And when you write that workflow, you probably are adding some plotting tools from packages, or you're relying on some other packages that are not essential for the full functioning of your package, but are essential for running the vignettes or those workflows specifically. Those type of libraries go into the suggest field or flag. I think field is a more proper name for calling these. And note that every field is just a name, which is reserved names. So these are keywords that make sense and are interpretable by DevTools, which builds the package. So in this case, so the workflows that I talked about are called vignettes. In that vignette, you will have a bunch of code that may rely on additional packages that are not essential they are not considered as dependencies for your software or package, but they are necessary to run the workflow. Those go into the suggest field. If you have functions that are essential for the full functionality of your package, they should go to the imports field. So that's the difference between imports and suggest. For my vignettes, I'm using R markdowns. So I'm relying on Knitr as the engine that renders my vignettes. And because I'm publishing this, I've published this on Bioconductor. So there's this Bioconductor specific field where I kind of mention which of the subfields or disciplines in biology or computational biology this tool belongs to or is relevant for. So this is a very comprehensive guide into how the description file looks like. R directory is, of course, where you keep all the R codes. And so let's, for example, look into one of these R codes. So see how I'm starting the R code with a hash followed by a quote, a single quote. This is the marked up language that I mentioned, that it's interpretable by the Roxygen 2 package. Whenever you have this flag, which is a combination of a hash followed by the single quote, that tells DevTools that this is a documentation. And DevTools uses Roxygen 2 package to interpret or to compile this into the help pages, which will appear under man directory. So all these RD files, say all of them are just generated automatically by Roxygen 2 based on your entry in the actual source file for that function. And this is something that you don't need to worry about. So when thinking about the package hierarchy, which consists of description file, namespace file, R directory, and man directory, these are the core ones. Among these, description is the one that you need to change and to update with your package-specific information or dependency, software dependency information. R is where you make individual scripts. That's a good practice to make individual scripts for each of your functions. If you have a set of related functions that you think it doesn't really worth having separate R functions for it, then you can put them in one, but you need to essentially repeat this pattern. You need to document them all separately using this kind of flags, Roxygen 2 flags. I think I might have an example where I have multiple codes into the same, Yes, I'm not sure where it is, but the general practice is that you can have multiple. This is one of the good cases. So in this case, this is like one function. This is another function, but I'm still using this Roxygen 2 flags to tell R and DevTools that these are different functions. So you can keep multiple related functions in the same .R script, but I think the general practice is to keep them as individual scripts. So how does Roxygen or documentation work? So for each function that you write, before that, you need to have these Roxygen 2 flags, and every line essentially makes some sense to Roxygen. So for example, the first line is always going to be the title of the function that appears, a short title or short description of the function that appears at the top of the man page when you use question mark function name. Then the rest of the lines are some brief description about what the function does, some overall overview. Then these dots at param, this @ sign is used to kind of load another kind of perhaps sub flags. So at param, for example, just says that X here is a random variable that goes as the input to this function. So this is now specifying the arguments to the function, compute a structure or metrics. And then I want to describe, what the type of each argument is. And that's through using that @param flag. So note that in this function, I'm just using simply 4 arguments, X, group, Y, and K. And for each of those, I have a @param that specifies what the argument is. What is its type? It's a numeric matrix. And what is it? It's, for example, a matrix of log intensities. Or in this case, K is numeric. So it's just one numeric. And it's, for example, the number of principal components used to do blah, blah, blah. So once you are done with the param, then you have kind of described your, I'm not sure if I have a compiled. So let's go back to this just because I want to make sure that you follow. If I can reduce the zoom over here and find my console. So let's say, for example, I want to know, so when you call the help page for this specific, okay, yeah. So when you call a function, see, you get the arguments, well, you get a description of the, like a title for the function. So that's the first line over here. I hope that makes sense. And then, you know, under arguments, when you specify each of the arguments individually and provide descriptions, this is really what is translated when you use the param function. Details is used to make more detailed description about how the function works and what it does. Return. So if you go back to this example, details will be translated similar to as done over here. Return what the function returns, and it's going to be similar to, there is no return over here because, well, load all doesn't return anything, but see, you realize that, you know, there's some description typically that how things are returned. And, you know, what it returns, references, you know, this is where you want to cite your publication, the publication that accompanies the method or the tool that's implemented here. Examples is this example session over here. So this is where you kind of provide a brief demonstration of how the function should be run. And more importantly, this .export flag, which makes sure that the package is exported and is accessible to everyone else. This is essential, and essentially what happens is that whenever you use the export, this function then will appear in the namespace. Namespace is something that it's, so you see that I've got export for all the functions that are in the package. This export makes sure that the function is properly accessible and loaded properly with its all dependencies. It's loaded properly when the user loads a package or uses library.package. Something that you want to be cautious about is not to change this by hand, because this is also generated by Roxiden. So the RD file, the documentation files that go under the man directory, and this namespace file, these are all automatically updated by Roxiden 2 using the functions that are I introduce later. So note that there is also some import from statements. Okay, so let me go back to my R code again. Let's look at this script. Here I'm using the correlation function. For example, I'm defining a new function that uses correlation list And yeah, correlation and dist. Correlation and dist are from the stats function, stats package. So you need to, again, using Roxygen2 flags, when your function is importing functions from other packages, you need to manually specify that using import from. So in this case, I'm saying that before you run this function, from the stats package, import core and dist. This is, I think, hopefully very straightforward thing. And so this will also be loaded back into the namespace. And when you do the man page, it will properly be propagated into both namespace and documentation package. Documentation files, not necessarily into the documentation, but namespace. So description is where you keep all the information or description about the package, but also dependencies and R version requirements. Namespace is something that you don't change manually, but rather it will be automatically generated or kind of propagated with Roxygen2. R is the directory where you keep all your R functions over here, and your R functions should come with these flags, Roxygen2 interpretable flags, which deals with both the proper export of the function, managing dependencies that the function has, as well as documentation. Something else, so what happens on the data directory when you write up your workflows, you need to import some data, particularly if you're submitting to Bioconductor or probably even CRAN. If you need to attach data sets to your package, these data sets are very small, so you definitely will have limitations in terms of attaching data to your packages. But if there is a data set that you want to attach to your package, they should be in R data format, and they should be kept into the R directory, which is not by default there. As you saw over here, it's not created by default. This is something that you need to kind of manually add. So we went through the R directory to the data directory. INSD, or sometimes it's also called as SRC. This is where the news file or any other non-R functions are kept. So in this case, for example, I'm using some Python code that I run from my package. And so the Python code goes into the Python directory under INSD. A good practice is to have this .news file, which is a LaTeX version essentially, and it's kind of documents that each version what was the change that was applied. For example, in version 0.9922, we made the initial submission to Bioconductor. I don't know, by version 1.3.0. We added new functionalities or just modified some bugs in codes. So these are things that you need to report to your user, and it's a good practice to have the news. But this is more probably, we should have it. It's a standard software development practice. It's better to have it, but it's required if you eventually want to aim to publish on CRAN or Bioconductor. Then we covered man. So this is where all the files that are required for R to bring up the help page when you type " my function. And again, these are automatically generated by Roxygen, and I'll show you how. Or I just rather comment on how, I guess. And then the vignette. So this is also not part of the standard kind of architecture, package architecture. But Bioconductor, for example, requires it. This is, so here I just have a RMD file that just demonstrates how one should run different functions that I've made available in MS Compute. So any questions are this? I think this was really 99% of a package, and how you should frame or structure your package, and how you should add documentation. Again, more information about kind of different flags that you can use with Oxygen 2, or different fields that go into the description file. These are all covered in the book. So if you want to be, if you want to have more information, you can go through them, but these are really like the basics. And I won't say basics because the basics are the ones that are here, but rather the essential ones that gives you a working package. Any questions so far?
Soroor, we don't have any question on the chat, but anyone has a question can raise hand. I myself have a question about naming our functions. How we make sure that we choose a proper name that doesn't overlap with other functions. For example, in very common packages like, I don't know, tidy or stats, about just naming our function, good practices. How we make sure, is there any source to check that, is it in whole R packages, is this name is in which packages we have this function name or something like that?
I think I think the book was kind of mentioning the resource. So this is the book. This is the website for the book, and I think there was some indication of naming. I think a general practice for naming the function is to use camel cases, so similar to what I've done here. So start with a lowercase. Then if you have more than one word in your function name, then the first letter should be capitalized. In terms of whether how to find out if it overlaps with packages in existing functions, I think there was an indication in the book, which, I think the ones that I've been doing so far are very kind of specific to my field. And so luckily I didn't have that problem of kind of overlapping names. But I think there was a mention over here. And definitely there are recommendations in the book on, what are the best practices for naming your functions. So I think camel is the most recommended one. But there could be other ways, for example, starting with a underscore. So this could be underscore compute a structure matrix, or maybe underscore is not fully recommended. I'm not sure. It's not really on top of my head, but yeah, I'm sure you can find
thank you very much.
over here.
And I have a very major question. All users use R, implement some algorithms, and every person use R in themselves, major or their fields in science or whatever. How do we decide whether our work was to create a package for it as a package or not? How do we decide? How do we make sure that our work was to create it as a package for everybody to use? This is the major question.
Yeah, that's a good question. So as long as you have more than 10 functions, I think that's a good point, even for your own personal use. That's a good point that you start thinking about writing it as a function. If you are using a set of functions, more than 3, more regularly, and on a regular basis, then it's probably easier for yourself to bundle them into a package, because then you can simply use library package, and then you will have access to all other functions. You don't need to source every individual file. So it's about the number of R files that you have. It's about the frequency that you need, that you use those R files, those R scripts. Then if it's scientifically, if it's a method that it's not implemented, so it's, for example, it's a method, the paper is highly cited, but the method is not implemented everywhere, is not implemented anywhere, and you think you have a very nice implementation of a series of methods. So that's a nice point of considering to building it as a package and distributing as a package if you know that people will need to use it very often. One more consideration is how new, how much it can contribute. So it could be that it's your own bright idea, or it's a method that accompanies your paper. So those things about how frequently the functions are used, do you have enough number of functions to start wrapping them into the package, and whether it can contribute to the community. And to be honest, there are a high number of packages that essentially just wrap functions in other packages. So essentially they just ensemble them onto one roof. It's not a new work, but rather it's kind of collecting different works from multiple places into one package. And I think another good thing is that, this is all about software development, and this is a very technique that's it's a skill that's in high demand. So it makes a difference in your CV if you say, if I have a package, it makes a very difference whether you're applying for positions or if you're applying for higher degrees. It makes a difference for them to see that you have an R package. Of course, if your package is highly used and you get high number of downloads, that's even a plus, that's a bonus. But it's also a good thing. So just a combination of those factors, I think is something that you need to consider.
Thank you very much. It was a very comprehensive answer. Yeah. And also another question comes up to my mind. And how do we, introduce or advertise or something like that, our package, or introduce our package to the community? Is it just, it stays on Quran and people search it, download it, or is there any other way to introduce, for example, our package that works in any specific field to the community of that? Do you know, or how do you introduce your packages?
It's with the publication. So publication is the main stream for introducing your package to the community. Usually you couple your publication with a code that implements the method that you describe in your publication, and then you have to aim for a good journal. If you manage to get it in a good journal, then people start to use it. Even if you don't get it to a good journal, nowadays we have this concept of preprints. So preprint servers. When you also deposit your work, your publication on the preprints, like bioRxiv or archive, people will read your work and they probably just give a try to your package. If they found it helpful, if the functions were functional, they were properly working, and the results were nice, they were happy with the results, they will start to use it. I mean, they start to, even before the publication, we've got this, people retweet publications. So it just spreads, right? Another way is just by presentation in conferences. Bioconductor, for example, has conferences every year, and it's people usually submit abstracts that I want to present my work, my package. That also helps. It can help to, depending on how what's the demand in the field. That can also help to visibility of of the package. Publications, conference presentations are really, or just preprints. If it's not proper publication, just as a preprint, that helps visibility of the package.
I also have a question. Can I ask?
Yeah, sure.
Hi, Nasrin.
Okay. Is there any team or something, somebody to measure our, our package correctness? How did they know that this package is correct? Or
so, yeah,
actually,
yeah,
that is also my question. That what is the process that a package from a very first steps in DevTools move to? I think it should be authorized to be on current website, right?
Yeah.
There's a process. Yeah. Thanks.
So I will. This is something that I will cover in the next slide. So this was a quick overview of what we covered about the structure of the package. So once you have that structure set up, and once you had your R scripts into the R directory, most importantly, and once you set up your description file where you list all your dependencies, etc., the first thing that you need to run is DevTools load all. So the load all function from DevTools, it kind of updates the, kind of rebuilds the package and makes sure that all the new changes are propagated into the package. Then what you need to do is to do DevTools document. That document will generate the RD files that will appear under the man directory. And finally, when you do question mark, when you load your package using library, my package, and when you do question mark my function, if you have updates, if you have run DevTools documents for your development, right? This is not as a user, but rather for your development. So say I make some changes to the documentation, I want to see how it appears, I just do DevTools document, and it generates the RD files for me under the man, then I can use load all and do question mark my function to see the help page, to see the changes in the help page. The last thing that you need to know, and that helps addressing both Nasrin and your question, and I keep missing your name, is use check build. So check build runs a set of different checks. That's it's the core checks by CRAN. It checks for something like, was the function written properly? For example, is it less than 80 characters? Is there a line with more than 80 characters? And things like this. Was there a proper export flag? Was there a dependency that was not listed? So these are everything that, this check build function checks for it. Is there a missing file? Is there an empty argument, or is there a, is there any error, any subtle errors? These are the stuff that will be picked by check build. So you as a developer, when you call check build, it gives you a report of what is right, what is wrong. And then you can go back and it tells you, for example, this line XYZ in file AB. So it all tells you about this one. So this is the way to check sure that you're adhering to the best practices for building software. And I think that brings, hope that answers your questions, but also that brings me to a summary of package development, the essential ones, the fundamental ones for developing packages. As I mentioned, all the DevTools workflow that I introduced, they are still valid, but I believe this is now the most recent way of doing package development. So I highly encourage you, and I think this is what the book was kind of recently updated to reflect, use this package, use this library. So I definitely encourage you to read the book, have a look at this, use this, which is also fully and comprehensively described in the book. And I just want to emphasize that versioning and licensing are very important in software development, which I touched them very briefly, but not fully, but you can see the book for more information. And I think that's really the end of all I needed or I'd like to present to you. If there are any more questions, I'm happy to answer.
That was a motivation for you to start learning or thinking of publishing your work as a package?
That's right. Yeah.
No questions. I have a question. Do we need like include a data set for our package? You know, a very a proper one, proper data set. I think it's a good practice to include with the data set that if anybody wants to test how this model, how this work works with that data set, sample data set.
Yes, it is a good practice to have a vignette and to have a data set. But as you said, so there is going to be limitations for, particularly if you want to publish on CRAN or a bioconductor, there will be file size limitations. I think they say minimum less than 10 MB. So the file has to be less than 10 megabytes, essentially. 10 MB, yeah.
Yep.
And so there will be file. So you have to kind of truncate your data. So yes, it's good to have one, but
a small data set.
That's right.
Very like 10 rows.
Exactly. This is practically what's happening in vignettes, that they only take the first top 10 of a larger CSV file, and they kind of compile it, save it into an R data file, and then make that R data file into the R directory. Yeah, so it has to be very small for file size considerations and limitations.
I think there is no question, so we can wrap up. Yeah.
Excellent. Yeah,
okay.
It was an honor I wish you all the best, and it was an honor to be able to present to my own fellows. As I mentioned, I've been doing this, I think, for Melburnians or Australians, but it was, I'm really glad to see that the same initiative is going on in Iran. And well done all. And I look forward to hear your success stories.